Now in this video, we'll be learning how to use comparative SOCS. So let me give you a little background for this problem. We have two catapults, catapult A and catapult B, and they're in a contest to see how accurately they can throw ping pong balls. And this is a scatter plot of catapult A and a scatter plot of catapult B, and 40 different times they tested it for this competition. Now this competition, they want to be within 5 centimeters. They have a range of 5 centimeters to try to get as many ping pong balls as possible. Okay, so now let's look at our question A. Comment on any similarities and any differences in the two distributions of distance traveled by balls launched from catapult A and catapult B. Okay, so some similarities. Both dot plots are approximately normal. So as you see up here, you have your centers and it kind of trails off like a general curve, and your center and your tails, which is approximately normal. And they both obviously have 40 points of data. And on catapult A's dot plot, now this is going over to some differences. There are apparently, or which appears to be, some outliers about 121 and 155. Compared to dot plot B, which seemed to have no outliers, and it's a pretty condensed graph. So those are some similarities and differences between the two graphs. So let's move on to part B. If the parents want to maximize the probability of having the ping pong balls land within this 5 centimeter band, which one of the two catapults, A or B, which would be better to use than the other? So now, I said the parents should go with catapult B, because the standard deviation of that scatter plot, or dot plot, is less than that of catapult A. So obviously, as you can see with the graph, these are, by the looks of it, much more condensed and together than these. So the standard deviation of this will be less, because the dots vary from this central point less than they vary in catapult A, which that means that the ping pong balls from catapult B will be less likely to go out of this 5 centimeter range than those of catapult A, and that's our goal, to get the most ping pong balls in that 5 centimeter range. So, and that's what I just explained right there. Okay. So moving on to question C. Using the catapult that you chose in part B, which was catapult B that we chose, how many centimeters from the target line should the catapult be placed, and explain. So if we go back to our data, catapult B, the median of catapult B is right around this 138 range. So that's where the center, where most of all the ping pong balls, or the majority of them, will be landing. So we want our target line, which is in the middle of that 5 centimeter zone that we're trying to make it into. The target line's in the middle of that, so 2.5 in. So we want our median, or the center of this, where the balls are going to be landing, to match up with the center, or the target line of the field. So if these two match up, we will have that will give us the most likely chance of getting the most ping pong balls within this zone, which will conclude our 3 A, B, and C questions, and will teach us how to use comparative SOCS.